What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 10.4, inscribed angles and polygons. We're going to be able to use those inscribed angles and then be also to use inscribed polygons. We do have some core concepts and some theorems we're going to talk about, so make sure your theorem sheet is ready. The first thing we're going to talk about is what is an inscribed angle, and that is what an angle whose vertex is on a circle and whose sides contains chords of the circle. So we see over here we've got a triangle here, and it's got some inscribed angles because of those criteria. An arc that lies between the two lines, rays, or segments is called an intercepted arc. So we have here the arc in that blue, and it's lying between two rays of that inscribed angle. Okay? If the endpoints of a chord or an arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. Okay? So angle B intercepts arc AC, but arc AC subtends angle B, and segment AC subtends angle B. Okay? Once we've got that information down, let's talk a little bit about how we can apply this. So the measure of an inscribed angle can be found by taking 1/2 of the measure of its intercepted arc. So again, this is a good picture to draw with theorem 10.10 on your theorem sheet. We have circle C, and the measurement of ADB, so this angle right here, would be 1/2 of the measure of arc AB. So we can say like maybe arc AB is 150 degrees. To find ADB's angle, we would just take 115 divided by 2, and we would get 75. Okay, so that's going to be a helpful way we can find those. Let's go ahead and try some together first, and then you can try some on your own next. The measurement of angle T is here, and what we want to do is find the intercepted arc. So the arc that is intercepting right now is angle RS. So to find this, I would just take 1/2 of the intercepted arc, which would be 48. So angle T is going to be 24 degrees. The measurement of QR is here. So we're going to have to do some extra work here. We know that the measurement of QT can be found by doubling its intercepted inscribed angle. So the measurement of QT is equal to 2 times the angle of R, which is 50 degrees. So that's going to give me 100 degrees. So I'm going to go ahead and label that there. Okay. Once I do that, I can see that TP is appearing to be a diameter. So if I already have 100, remember this entire half circle should be 180 degrees. So QR would just be 100 degrees less than that. So the measurement of QR, minor arc, would be 80 degrees. Okay. Next up, we've got an example here, and it said, find the measurement of arc RS and the measurement of angle STR. What do you notice about the angle measurement above STR and RUS? So the arc measurement of RS, let's start here. Here's RS, and it's being intercepted with this angle here, which means I can find the measurement of RS arc by doubling 31 degrees. So the measurement of RS's arc is 62 degrees. Now STR is here, and STR is also intercepting arc RS, so I could just take 1/2 of that. So the measurement of angle STR is 31 degrees. So the measurement of angle STR is equal to the measurement of angle RUS. Almost like these are corresponding angles because they're both intercepting that same arc. So, inscribed angles of a circle theorem can be this, kind of what we saw before. If two inscribed angles of a circle intercept the same arc, then those angles are congruent. So we just proved that with an example, okay? If you need to, pause the video here and draw this in your theorem sheet, that'd be good, just so you can have an idea of what it looks like and what angles could be matching. Don't forget your letters as well. Next up, if I know that the measure of angle E is 75 degrees, find the measurement of angle F, okay? So here's 75 degrees. Notice that it's intercepting arc GH. The measurement of angle F is also intercepting GH. So since they're intercepting the same arc, the measurement of angle F is also 75 degrees. Okay? Let's see if you can try some of these on your own. We're going to go ahead and pause the video here, try questions 1, 2, and 3, and when you're ready to check, go ahead and click play. All right, so number 1, find the measure of the red arc or angle. So here's my angle that I'm trying to find, and it's exactly half of my arc, so that'd be angle G is 45 degrees, or even say, let's say angle HGF. Okay, here my arc is already positioned, so I'm just going to double my angle, and I'm going to get 76 degrees. And then lastly, I am looking for this matching angle. This angle is intercepting the same arc ZW that the previous angle was, so that means it is also equal to 72 degrees. Next up, we're going to look at inscribed polygons. I apologize about the bell. All right, an inscribed polygon is a polygon when all its vertices lie in a circle. The circle that contains vertices is the circumscribed circle. So that just means it's going around the shape, okay? So we have some theorems about those things. The first one talks about an inscribed right triangle. An inscribed right triangle just states that it's inscribed in a circle, the hypotenuse is the diameter, okay? So we can see that, which means this would be my right angle. So conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the opposite angle is that right angle. So this would be a good picture to draw if you don't already have that drawn on your theorem sheet. And then lastly, we have an inscribed quadrilateral theorem, and that just states a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, okay? So that means the measurement of angle D added to angle F and the measurement of angle E added to angle G should be equal to 180, okay? So opposite angles across from one another, as long as they are quadrilateral, those are my supplementary angles. Take time now to draw some pictures here on your theorem sheet, and when you're ready to get going, let's click play and try some questions. So these two, find the value of each variable. So let's start with x. This one is showing that it's a right triangle, so 2x is equal to 90 degrees because it's opposite of the diameter, which is the hypotenuse, so x is equal to 45. And then letter B has no calculations necessary because if you have your opposite angles, then they should be supplementary, right? So we have y plus 120 will be a supplementary angle, equals 180, and z plus 80 would also equal 180 because they're both supplementary. So y would be equal to 60 degrees, and z is equal to 100 degrees. Okay, so those are how those are going to be able to be done. So let's look at our last little pieces of information. This one would be a good idea for you to pause, try on your own. When you're ready to check it, go ahead and click play. All right, so for my first one, angle L, or letter X, is equal to 90 degrees because it's across from the diameter. And then to find Y, I just have to find the remaining piece. 90 and 40 is 130, so Y should be 50 degrees, okay? For 5 and 6, these are both quadrilaterals, so my opposite angles are supplementary. So y plus 68 equals 180. That means y is equal to 112 degrees. X plus 82 equals 180. So that means x is 98 degrees. And then lastly, we have some algebraic expressions here to solve, still using that same idea we did in number 5. Opposite angles are supplementary. So c plus 2c minus 6 equals 180. Let's go ahead and take time and solve that first. 3c minus 6 equals 180, or 3c equals 186. So c is equal to 62. Right? 186 divided by 3. There we go. Okay. Then we've got 8x plus 10x is equal to 180, or 18x equals 180, which means x has to be 10. Okay? That'll conclude our video on 10.4 inscribed angles and polygons. Thanks so much for tuning in, and we will catch you next time. Have a great day.